There's a tiny switch hiding inside every PLC output card. It is also inside every chip, every phone, every computer. Billions of them, in fact. It has no moving parts. It never wears out from switching. And it is the single most important invention in modern electronics. It is the transistor. Most engineers use them every day without ever really picturing what one does. So in this video, I will fix that. I will show you what a transistor actually is. The two families you will meet, BJT and MOSFET, why we mostly use it as a switch, and how that exact switch becomes a PLC transistor output. Let's start with the one job it does. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC programming and the rest of this video free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the transistor. So what is a transistor? At its heart, it is a semiconductor with one job. A small signal controls a much larger current. That is the whole idea. Think of a tap. A light touch on the handle controls a heavy flow of water. The transistor does the same thing with electricity. A tiny input commands a big output, and it can do that in two ways. It can amplify, turning a weak signal into a stronger copy. That is how it works in audio and radio. Or it can switch, slamming the larger current fully on or fully off. In industrial gear, we care almost entirely about switching. So that is where we're going to live for the rest of this video. Now the two families you will actually meet. The first is the BJT, the bipolar junction transistor. It comes in two flavors, NPN and PNP. A BJT is controlled by current. You push a small current into a terminal called the base, and that lets a much larger current flow through the device. More base current, more output. The second family is the MOSFET. A MOSFET is controlled by voltage instead. You put a voltage on a terminal called the gate, and that switches the main current on. The gate draws almost no current to hold it there, which makes MOSFETs very efficient. Do not get lost in the physics. Just hold one idea. A little bit of input, a base current, or a gate voltage, commands a lot of output. Here is the part that matters most for automation. The transistor is a switch. Drive it hard enough and it saturates. Fully on. It behaves almost like a closed contact with very little voltage across it. Now, take the drive away. It cuts off. Fully off. It behaves almost like an open contact with almost no current through it. On-off. A switch. And it is a remarkable switch. No moving parts. No contacts to bounce or pit or burn. It is silent. And it is fast. It can switch millions of times a second without breaking a sweat. That is exactly what every logic gate, every chip, and every PLC output is built on. Tiny switches flipped by tiny signals millions of times over. Now bring it on to the PLC. A transistor output PLC switches its loads with these solid-state switches instead of mechanical relays. And you will see two styles. Sourcing outputs are PNP style. They push positive voltage out to the load. Syncing outputs are NPN style. They pull the load down to the common. I have a separate video on NPN versus PNP and one on testing your inputs and outputs, both linked below. There are trade-offs. Transistor outputs are DC only. They cannot switch an AC load. And each one has a current limit, so you do not hang a big motor straight off it. But they switch fast. Fast enough for high-speed counting, pulse trains, and PWM. A relay output simply cannot keep up there, and it wears out from the constant switching. I have a full video on relay outputs, also linked below. So here's what to walk away with. A transistor is a semiconductor where a small signal controls a much larger current. A BJT is controlled by a base current. A MOSFET is controlled by a gate voltage. And in automation, we mostly use it as a switch, saturated on, cut off, no moving parts very fast. That is what a PLC transistor output is. A solid-state switch for DC loads, sourcing or syncing. Fast enough for pulses and PWM. Get that, and every output card stops being a mystery. Now, go make it concrete. If you want to practice PLC programming hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe. New video every Tuesday. See you in the next one.